Find the indicated limit if it exists. So we're finding the limit of 1 over x plus 2x divided by the quantity x plus 1, all divided by 4 over x as x approaches -1. If we use direct substitution, this second fraction in the numerator will result in a 0 found in the denominator. So we're going to have to rationalize this. To do so, we're going to begin by finding common denominators for the rational expressions in our numerator. So we're going to multiply the first fraction by x plus 1 over x plus 1, and we're going to multiply the second fraction in our numerator by x over x. So this will keep our limit generally the same, but now it's going to become x plus 1 over x times x plus 1 plus 2x squared divided by x times x plus 1, all divided by 4 over x. Okay, so now what we can do is we can combine these two rational expressions together because we have that common denominator of x times x plus 1. So we have the plus sign in between, and we have x plus 1, all over 4 divided by x. Now, in order to just get a regular rational function, instead of a rational over another rational, we're going to multiply both the top and bottom by x over 4. When we do that, everything in the denominator will cancel out, as well as these x factors or values, so they cancel out. So we will have remaining 2x squared plus x plus 1 divided by 4 times x plus 1, and we're taking the limit of this as x approaches -1. Now if we use direct substitution in this expression, we will get 2 times -1 squared minus 1 plus 1 all over 4 times -1 plus 1. Well, in both the numerator and denominator, we have -1 plus 1 canceling out. So we'll have 2 divided by 4 times 0, which is 0. And we can't take the limit of this. Like it appears as though it's not going to exist. And let's verify this graphically. So it appears, because we can't evaluate this after we simplify, that it does not exist. Let's actually look at the graph of this. So if I switch over, this was the simplified version of our function, and we can clearly see that we have an asymptote at -1, and if we were to approach -1 from the left, we would approach -infinity, and if we approach -1 from the right, it would go to +infinity. And since these limits do not match, the limit here does not exist. So this confirms our answer here indeed does not exist.